In today's video, we're going to be factoring using the trinomial pattern. To do this, we're going to replace the common factor with a variable. Let's get straight into an example. Let's say we had this. How would we factor it? Believe it or not, this is still in the form ax squared plus bx plus c. But it just looks different. So like I said in this page where we're replacing the common factor with a variable, we have a common factor here. We have this x plus 1 and x plus 1 on both the a term and the b term. So our aim is to replace those with a common variable. This could be anything. We could replace it with b or just a's or z's, whatever we want. So, but the important thing that I find is you remind yourself at the side that you need to, when you state it, that you've replaced this with this variable. And the simplest way that we do that in math is to say, let x plus 1 equals x. Now, notice I did not do x plus 1 squared with the squared up here, because that squared is not common to this side. There's no squared on that side of the expression. So we're going to let it equal x. You could use any other, letter that you want, but x is what I'm going to go for. And now we are going to rewrite the question or the expression with the variables now inside, right? We're going to take out the x plus 1 and we're going to just change it to x. So it's going to be x squared minus 6x minus 16. Now this looks a lot more similar than with the ax squared plus bx plus c. So now this looks very familiar. We can now decide to factor this, right? Using the trinomial factoring. Again, what two numbers multiply to give us 6 but add to give us multiplies to give us 16 but add to give us 6. And again, keeping the signs in mind, but we have 8 and 2, so we're going to have two brackets. We're going to have x in both brackets, and we're going to have 8 and 2 in both brackets, right? Because 8 times 2 is 16, and 8 plus 2 is 8. 8 and 2 would give us -6, so 1 has to be a negative. So we're going to have a negative with the 8 and positive with the 2. And how do I know? Again, you could do trial and error, but over time, I just kind of know if a negative is behind a number, and I have two numbers, one big one and one small one, the bigger one is going to be the negative number, right? Because the small one is not going to be able to cancel out all the negatives in the bigger number, right? So that's how I kind of figured that out. So now we're not done. A lot of the time people would think, oh, we're done, yay, let's go. But again, we didn't get x's in the question. We got x plus 1 in the question. So now we have to plug that back into our factored form and do like our foiling in order to be done with this question. So in order to do that, I'm going to go to the next page, write the answer again. We have minus 8 and x plus 2. Now we're going to replace it with x plus 1. So here I like to use a bigger bracket that kind of opens up because x plus 1 was in a bracket. Right, so we have x plus 1 minus 8. And then we're going to have a bigger bracket again. Again, x plus 1 minus plus 2. We're not going to add any squares to any of these because, again, remember, we already factored that with the squares in mind. So we're just going to replace it with what we took out in the first place. So basically, we could actually get rid of these brackets, right? But sometimes I like to keep it to look really nice. But then if you get rid of it, it might actually be easier to see what we're doing here. So we have x plus 1 minus 8. Again, collect like terms, right? It's more so collecting like terms than foiling, actually. So we're going to collect the like terms. So we're going to be left with x, right, minus 7 on this side. And then on the other side, we're going to be left with x plus 3, right? Because then we're going to add these two. We're going to add those two or subtract those two. And this now is our final answer. Look at the difference between this and this. Those are two completely different answers. So that's why you need to replace your x back with what you took out. And now we have this as our final answer. So I'm gonna do another example. This time they're not gonna be like terms. How can we still solve this using the trinomial pattern? Whoa. This looks like a huge thing. But then again, we're going to replace the brackets with variables. Now, they're not like terms. So we cannot replace them with the same variable. So we have 2x minus 3 is different from y minus 4. So we're going to let 2x minus 3, just that, leaving the squared, we're going to let that equal a. And then we're going to also let y minus 4 equal something else. Let's say b, right? We can't let both of them equal a because then that's just kind of confusing, right? So we want two different things because both of them are different. So we're going to, again, do the same thing we did for the last one. Replace it. So we have 27a squared minus 75b squared, right? So now we're going to, again, factor this. Okay, and to factor again, the first step is always to get out your like terms. And I can already tell that there's a like term in this, which would be a 3. Because then 27 would be a 9. Giving the a squared to be a 25. Keeping the b squared because those are not terms. And then now we can, both of these are, we're going to use a difference of squares to solve this because both of them are now common factor. They're now perfect squares and they're binomials and we have a negative sign in the middle. So we're going to use the difference of squares. So 9 is going to be broken down into a 3 and a 3. The a is a perfect square, so that's going to be broken down to a's. And the 25 is a perfect square. We're going to have different signs. We're going to have 5b, 5b. So now this is factored, but we're not done. Again, we're going to replace wherever we see our a with 2x minus 3, right? From this last page, we have 2x minus 3 for a, right? And then we have y minus 4 for b. So we're going to replace our a's with that and replace our b's with that. So it's going to get a little tedious, but we're going to do that. So we're going to have 3. And this is why I want us to get into the habit of using brackets. Because if I just put the 3 here and then put my 2x minus 3 without the brackets, I could as well just look at it as a 32. Or imagine that just the 3 will be multiplying the 2, but the 3 is actually multiplying everything in the bracket. So we have 2x minus 3. Again, we're going to subtract from that 5. But in here, we have a y minus 4. If I'm not mistaken, I'm going to go back and check that. And then again, we have to do the same thing for the other bracket. I'm running out of room, so we're going to zoom out here. Okay. We're going to have the same thing, right? It looks very similar to this, so I'm just going to copy that. But instead, the only difference is the signs are going to be different. We're going to have 3 in bracket 2x minus 3. Plus 5 y minus 4. Let's go and make sure that that's right. Minus 3 y minus 4 correct. So now we're going to fold the 3 into it, fold the 5 into it, fold the 3 into this one, fold the 5 into that one. Then we're going to get our final answer. Remember, this 3 on the side right here needs to come down with it. It's not really doing much, but it still needs to come down with it. So 3 times 2 would be 6x minus 9. And then we're going to have... Now, I can get rid of the brackets at this point if I want to. So we have negative 5y plus 20. And then we're going to do the same here. We're going to have 6x minus 9. For this time, we're going to have positive 5y minus 20. All right, so this is what we're going to have. And now we're going to collect like terms on the inside. So we're going to, again, bring the 3 down with us. So here we have 9 and 20 are like terms. These are 6x and 5y are not like terms because they're different exponents. Different variables. So we're going to collect like terms. So here we're going to still have 6x minus 5y. But we're going to end up with a plus 11. Then for the next one, we're going to have, again, collecting the like terms, 6x plus 5y. But this time we're going to have a minus 29. And now, this is our final answer. Looks a lot different, but if you just kind of get the sense of replacing things, bringing out things and replacing it for other, for variables, we're going to be set and good to go. And so this is pretty much factoring using the trinomial pattern in a nutshell. Just replacing the variables with, the things in brackets with variables, factoring that, and then replacing it back for what we're given in the equation. And that is how we're going to get a great answer and actually come into conclusions to our final answer. So I hope you guys enjoyed this video, or learned from this video rather. See you guys in the next one. Bye.